Now that we know the characteristics of carbon and the importance of carbon-containing compounds, let's move on and understand how the bonds between carbon and other elements or atoms are formed. Now, over the few chapters, you have learned about something called as ionic bonds. Now, in this ionic bond, you have a metal which loses an electron, and you have a non-metal which gains an electron, and then you have the bond which is formed. But over here, you have carbon, and some people might be saying, carbon being in a non-metal can gain 4 electrons and hence have a very stable C4 minus configuration. But this is not possible. The simple reason being, when you have 4 extra electrons in the outermost shell, it is too much to handle for barely 6 protons in the nucleus, and hence it would require enormous amount of energy and would definitely make the atom itself, or the ion, which is in this case, unstable, and it is not very much viable for the atom itself. So this is not possible. And some people might even say, if this is not possible, that it forms a C4 minus, maybe it could form a C4 plus by losing 4 electrons in the outermost shell. Now, this is also not possible, as even this would require high amount of energy, which is not viable for a small atom like carbon. So, you might be thinking, how is it that we have bonds with carbon and different atoms and elements? It is simple. Rather than giving or taking, carbon uses a sharing policy, and hence it shares its electrons with other atoms and elements. So how does this happen? For this, what we'll do is, we'll use the Lewis dot structure and understand. For simplicity, let's consider a hydrogen atom. So you have 2 hydrogen atoms, each one with the obvious 1 electron in the outer and the only shell that it has. And for stability, both need 2 electrons in the outer and the only shell that it has. So give and take is not possible, just like the carbon atoms. So what happens is, they both come together, they share their electrons, and both these electrons, they spend equal amount of time in each of the hydrogen atom, and hence you have a diatomic molecule of hydrogen which is formed, which is H2. Now let's have a look at nitrogen. The nitrogen also has 5 electrons in the outermost shell. Now what it does is, for stability, it forms an N2, which is diatomic nitrogen. So you have 2 nitrogen molecules which come together, and they both share 3 electrons. These 3 electrons from each of the atom spend equal amount of time in both the nitrogen atoms, and hence you have the bond of N2 formed. But over here, there are 3 electrons which are formed, and hence you do not have just a single bond, you have something called as a triple bond. So you represent it by 3 lines. Now, let's move on to the guest of honor, carbon. Now, carbon, let's try and make a methane molecule using this dot and cross structure. If you do remember, methane is CH4, which is natural gas. And as we have said already, that carbon has a combining capacity of 4. That means it can attach itself to 4 different atoms. So, you have 1 carbon, you have 4 hydrogen. Now, each of these hydrogen shares an electron with carbon, and each of these electrons spend equal amount of time in the hydrogen and the carbon orbit. And this is how you have the formation of methane. Similarly, all the other carbon atoms are formed. The carbon has a good combining capacity with elements like oxygen, phosphorus, nitrogen, sulfur, hydrogen. And with this, it has a tendency to form many other compounds